expression for capacitance of a parallel plate capacitor. Consider two plates equally charged with surface charge density sigma, right? Separated with a distance d with a plate area capital A. Two plates uniformly charged with surface charge density sigma, distance between the plates small d, and area of the surface is capital A. The surface charge density on each plate can be defined as charge per unit A. Now, electric field intensity in between the plates is given as E due to the first plate and E due to the second plate. Now, consider a छोटा सा charge, point charge if we place here, then अगर इसको पॉजिटिव चार्ज मानते हैं तो फर्स्ट प्लेट एंड सेकंड प्लेट both would, one would repel, second would attract, but both the field would be additive in nature. So by the Gauss's application, put the value of electric field, it's a sigma by 2 epsilon 0, medium permittivity, medium is vacuum. This is another sigma by 2 epsilon 0. Add it. Make sure this is E electric field, this is epsilon 0. So this is sigma by epsilon 0, right? Now put the value of sigma from first. So this would be E, it's Q by A epsilon 0, right? Now potential gradient E is equal to V by D as a definition of electric field. Electric field is potential gradient. Use it. So this would be V by D is equal to Q upon A epsilon 0, right? By the definition of capacitance, Q is equal to CV. So it is V by D and this is CV upon A epsilon 0. V cancel out and C is equal to epsilon 0 A by D, right? This is number 3. This is expression for the capacitance in vacuum when nothing is placed between the plates, right? It only depends upon physical parameters, medium permittivity, area of the plate and separation distance. This does not depend upon any charge or potential applied. It only depends upon physical parameter. A bit modification can be added. अगर इन दोनों plates के बीच में कोई medium insert कर दिया जाए, then it would be. सोचो this medium filled with any dielectric of dielectric constant K, then the new capacitance with medium would be epsilon A by D. The only one change, epsilon 0 replaced with the epsilon, and the relation of epsilon upon epsilon 0 is capital K. K is dielectric constant. So this medium, this become K epsilon 0 A by D, or further you can go for this K time to the C vacuum. So when we introduce any kind of medium between the plates, capacitance increases. Why? K is always greater than or equal to 1. For air it is approximately 1 and for metal it is infinite. K कभी भी 1 से छोटा fraction में नहीं आएगा. It is always greater than 1. So this is the capacitance with or without medium. Further we can modify this for the small reason. We will go for the separate, but first we will go for the part that energy stored in a capacitor. जब एक capacitor को charge किया था तो it store actually electrostatic energy. So let me go for that. Energy stored on a capacitor. ठीक है? Same considerations. Consider a capacitor with the same parameters. It's energy stored on a capacitor in a capacitor, right? So consider a capacitor is charged and any instantaneous charge is Q equal to C. Now work done in further delivering it some charge, right? So let further charge is a small fraction of charge dq. Work done, definition is charge into potential. The instantaneous potential from the first equation is considered to be V, and the charge, small fraction of charge delivered is dq. Right? From first, replace the value of V, and this is work done. This is dq as it is, and this is q by c. Just rearrange both the things. So q by c, it's dq. Integrating both sides, I'm doing it here. So integrating, it's dw, and right hand side it's q by c dq. Put the limits. I'm choosing another symbol q. So this would be w. C, as we said, C does not depend on charge, C only depends on physical parameters, so consider to be constant. So bring it out. This is q dq, and this is w, it's 1 by c, and this integration would be q square by 2. Right? Put the limits. So this become half q square by c. Right? Limit capital Q minus 0. This work done would be stored in the capacitor as electrostatic energy. So ultimately I replace the symbol W with the U energy. It's half Q square by C. This is one form of electrostatic energy. Using the definition concept Q equal to CB equation, first can be written as U is equal, I am replacing Q. It's a half C square V square upon C. Ultimately this become half CB square. This is the second format. Now if we replace C, then this U is equal to half Q square. C value is Q by V. Q by V. One Q get cancelled out. So ultimately this becomes half Q into V. Right? These are the three different formats of the energy stored in a capacitor. Am I clear? So this is a small topic based on the expression of capacitance and energy stored.